This is the lesson from Chapter 5, Section 5, titled Standard Form Day 2. So we're going to take a look at what standard form is. And standard form could really be anything, whatever standard somebody wants to give something. But what we typically think of standard form is this: ax plus by equals c. And so ax plus by equals c. So a stands just for a coefficient in front of x, b is the coefficient in front of y, and it equals a constant. And typically we want these variables, these coefficients, to be integers. And so these should be integers, and even more so, at times they like the a term to be a positive integer. And so that's going to end up being a whole number in front of the x term. The a term should be a whole number where b could be positive or negative. C should also be an integer as well. So that's what we're looking for when we put it into standard form. So if we had y equals x minus 4, to put it in standard form, I would subtract the x from all sides, and I'd have negative x plus y equals negative 4. So again, I want that x term to be positive, so I just distribute that negative 1, or multiply all numbers by negative 1, and I'd have x minus y equals positive 4, and that would be standard form. So that's what standard form is. There's really no reason to change y equals x minus 4 to standard form, except just to put it in that form, just to practice, because this gives us a lot more information. I've got the slope of the line, the y-intercept, where here I could find the x-intercept and the y-intercept, but oftentimes we want to know what that rate of change is. So anyhow, this is standard form. That's the way we'll leave it. So on this one I'd have to distribute. So I've got y minus 4 equals 5x minus 40. So again, I want to get the constants onto one side. So I'm going to subtract the 4 from all sides, and I'll subtract that 5x from all sides. So when I do that, I've got now negative 5x equals, oops, I got the y in there also, so let me go ahead and write that in there. And so I've got the negative 5x plus y equals, and this would make negative 44. So if I divide or multiply everything by negative 1, it'll switch all the signs. So 5x minus y equals positive 44 would be the standard form that we're looking for. So on this one, distribute the negative 3 over both terms. I'm left with y plus 6 equals negative 3x minus 3. So I'll subtract the 6, and I'll add the 3x to all sides. And so when I do that, hey, that gave me a positive 3x. That's good. That's in standard form without having to multiply everything by negative. So I'm left with the 3x plus y minus 9 is the standard form we'd be looking for there. On this one, first step I'm going to do is get rid of that fraction. And so I'll multiply by a 5, and that will change it to 5y equals negative 3x plus 10. So every number gets multiplied by 5. So now I'm just going to add that 3x to both sides, and that leaves me with 3x plus 5y equals 10. And that's the standard form I'm looking for. On this one, same sort of thing. I'm going to get rid of that fraction. I'm going to multiply by 2, every single number there by 2, and I'm left with 2y equals x minus 10. So I got to subtract the x from both sides, but it leaves me with a negative x, and I want that x to be positive to put it in the correct standard form, so I'll go ahead and multiply by negative 1, and I'm left with x minus 2y equals 10. So on the last one here, I'll go ahead and I'm going to get rid of that fraction. I'm going to multiply by a 9. Just multiply every term by 9, so I don't need to multiply the stuff inside the parentheses by 9 though. So I'm left with 9y minus 27 equals negative 7. Still have this negative 7 and that x plus 4 inside some parentheses. So now I have to distribute. So I'm left with 9y minus 27 equals negative 7x minus 28. So I'll bring the 27 over, add it to both sides, and I'll bring the 7x over. So I'll add that to both sides. And so that leaves me with a 7x plus 9y equals, and I add the 27 and negative 28 makes negative 1, and that is standard form. So there it is. So those are standard form, writing it in standard form from a form that wasn't standard to start with, and let's take a look at this problem. It says you have only nickels and dimes in your piggy bank. When you ran the coins through a change counter, it indicated that you had 595 cents. Write and graph an equation that represents this situation. So let's do this. We'll call some variables. We don't know how many nickels we have. So let's say n equals the number of nickels. And then I'm going to say maybe like d equals the number of dimes. And now let's try to write an equation to represent this. So I know I had 595 cents. I just had nickels and dimes. So I know there's 5 cents in a nickel. So 5 cents times the number of nickels plus 10 cents times the number of dimes is going to equal 595 cents. So now I've got an equation. So this is a good one for the intercept method. So I'm going to set d equal to 0 and find out how many nickels I could have had if I had no dimes. So I'll do 5n equals 595. Do the division, it looks like I'd have 119 nickels. Where if I solve for d, if I set 5n equal to 0, I'd have 10d equals 595, and that would give me d equals 59.5. So I couldn't just have dimes. I had to have some nickels there. And so let's go ahead and graph possible solutions. And so let's say that the y-axis represents the number of nickels. Now in this case, typically we have the independent variable on the y-axis, the dependent variable on the y-axis, independent variable on the x, but there is no dependent variable this time, so neither depends on the other, they're just dimes and nickels. So it's arbitrary which side I put it on. And now I'm going to go ahead and write down what I have. I definitely would have a whole lot more nickels than dimes because nickels are worth less than a dime. So I'm going to have a way of getting up all the way to 119. So I'm going to go by maybe 20s. Let's see if that works here. So I'll say this is 40. And it doesn't look like that's going to work because this would be 60, 80. Maybe it will. Okay, so this is 80. This would be 100. This would be 120. Let's see, 120 there. And then this would be, so that is definitely going to work. So I wonder if I could go even less than that. So 20, 40, 60, 80, 100, 120. If I went by 10s, 15s would be a little bit tougher. So I think I'll stick with the 20s here like I end up having. So I'll end up putting a dot right below this line. So that represents the intercept for the n value. Now over here, let's go by tens. So this is going to be 20 here. This will be 10, 20, 30, 40, 50, 60, and 70, 80. And so 59.9 is going to be right about there, really close. So when I draw the line between those points, if I draw it really carefully, I could end up gleaning some information from that. Again, if I had a really nice straight line, I could, because then what I could do is I could find out how many, if I went over to like 80, I could go over straight over and then down, and that would tell me how many dimes I would have. So what they want to know is, what are 3 combinations of nickels and dimes you could have in this situation? So if we went ahead and we could have any number, so here the answers could definitely vary. So let's say I had, how about 50 dimes. 50 dimes. And so if I had 50 dimes, that would be equal to, so 50 times by 10 would equal 500. And so I need now 95. So I'd have to do 95. How many nickels would that be? So 5n equals 95. And do the division, and I see that would be 19. So that could be one scenario. So I could have n equals 19 and d equals 5 or 50. And so that would be like 19 or 50 comma 19 in my case, because I did dimes and then nickels. And so that's just an example. Another one, just one more here, would be, let's say I had 40 dimes. D equals 40. So 40 times 10 gives me just 400. So that's $4, And so if I need to get up to $5.95, well, 5 times n equals, and the remaining would be 195 cents. And so if I went ahead and did the division, 5 goes into 19. We have almost 4 times, only 3 though, and there are 4 left over, so 39 times. So 39 times 5 gives me the 195. So that's 45, and 15 plus 4 does give me 19. So again, another answer could have been 39, and those are my nickels, and my dimes were 40. So those are just 2 solutions, and that's what I'm looking for there. So those are types of problems that you're going to end up seeing on tonight's homework. Good luck.